All right, so for the examples of the work, this is an example of where we have a parallel line situation. You have a transversal crossing it, and we've created our corresponding angles. So just the easy stuff, match them up. In this case, angle A, we want to know its value. We know that its corresponding angle down here is 126, so that because these lines are parallel, angle A also has to be 126. So the math looks like this. Simply write the angle name. In the jump book, you'd have angle A equals, and then there'll be a nice straight line, 126 degrees. Beside it, write the reasoning. Now, the shortcut for corresponding angle theory is CO and then AT, so CoAT. All right. The reason that A equals 126, corresponding angle theory. Other examples in your work look like this, where you have actually two sets of parallel lines that cross one another, and you have to kind of sort out where the corresponding angles are. Does this one correspond to E, or does 110 correspond to E? Well, E is in the same spot, the bottom right-hand side, as 110. So angle E corresponds to 110 degrees, therefore angle E is 110 degrees. So angle E equals 110 degrees. Because of the corresponding angle theory. And you have a 70s in the same spot as angle F, top right-hand side. So you have angle F is equal to 70 degrees. Same reasoning, corresponding angle theory. Right? It's going to get a little harder near the end, so I'll show you one more example. So questions like this one are going to pop up near the end. Bob thinks that angle A right here, I was going to draw in that angle symbol. Angle A is equal to 105 degrees. Is he right? And that's something you're going to have to take a look at and decide. Take a look at this diagram here. What do we know about it? What don't we know about it? Pause this, think about it, write a quick answer, and then I'll walk you through it. Okay? All right. So hopefully you paused it, wrote a quick answer, and then we'll see how you did. It has to deal with the fact that, take a look at these two lines. They're straight, they're running side by side. What are we not told? We're not told they're parallel. So we actually don't know if A corresponds in value to this angle up here, 105. We'll call this angle B up here. We don't know if angle A corresponds to angle B in value. It's in the same spot, so they're corresponding angles, but they're not necessarily the same in value. Why? Because you're not told that this line, I'll just call it line M and line L, you're not told that these two lines are parallel. So is Bob right? Based on what we're given, Bob's wrong. Bob is wrong based on what we are given. So let's change that to an I. Keep your little finger away from that off button. Hang on a sec. So again, we change the line style. I don't know why it always does that. We do not know that M is parallel to L. All right, we don't know that. Okay. Therefore, we can use another theory we know. Supplementary going across. We do know this is a straight line, and we do know L is a straight line, so we know 80 plus A has to equal 180 degrees. A plus 80 has to equal 180 degrees. Why? SAT, supplementary angle theory. All right. So if we take 80 away from this side, and we take 80 away from this side, angle A actually equals 100 degrees. All right, so Bob was wrong because he assumed, he knew that these angles were corresponding, But he didn't think to remember that they have to be parallel in order for corresponding angles to be equal. And that's something you're going to have to look at, all right, when you're doing the homework. Are these lines parallel when the transversal cuts across? If they are, then you're going to create equal angle clusters. If they're not parallel and you're not told they're parallel, do not assume they're parallel, all right, unless you're told.